Hello and welcome to this lecture on life table functions and the survival models. My name is Sheila Masaku. In this lecture, we will describe the future lifetime random variables. We will also describe the life table functions. We will then explain the links between different life table functions. Lastly, we will perform basic calculations involving life table functions. Well, let's begin. We start off with the complete future lifetime of a life currently aged X. This is denoted by capital T with a subscript X. This random variable measures the time in the future from the current time when this life is aged X up to some point in the future. The shaded part here shown is the future lifetime of this life. It is uncertain because we do not know when this life will die. On the other hand, the duration of life that has been lived by this life is not a random variable. So from the time this life was born to a duration of X years, here is certain that this person has lived for X years and now they are aged X. But we don't know from this point of age X up to some point in the future, we do not know that this person will actually survive those years. That's what makes this future lifetime a random variable. Now, Tx is a continuous random variable. It is continuous because the future lifetime can take on decimal values. If we are only interested in the integer part of Tx, we would need to describe the quartate future lifetime of a life aged X denoted by capital K with a subscript X. This one is a discrete random variable and it is the integer part of Tx. For example, if T20 is equals to 30.1 years, say, it means that right now this life has lived for 20 years and is now 20 from time 0. Now, from the current age of 20 up to some point in the future, we would say it is 30.1 years. It means that the complete future lifetime of this life whose current age is 20 is 30.1. But we don't know for sure that this person will live for 30.1 years from the age of 20. That is what makes T20 a random variable. Now, since the quartate future lifetime of this life can only take on integer values, for this example, K20 would only be 30 years. We now turn to the survival and death probability functions. The survival probability function of Tx is denoted by Sxt. This is a probability that a random variable Tx will be more than T years. It calculates the probability that the life aged X will survive at least T years from now. It is also expressed as a Tpx. That is why Tpx is known as the survival function of a random variable Tx. For example, we do the substitution. Where there's the t, we replace it with the duration of 10 years. And where there's the x, to represent this life's age as 5 years. Then we are saying 10p5 is the probability that a life currently aged 5 years will survive at least 10 years from now. The other side of things is the death probability function of Tx. This is denoted by fxt. It calculates the probability that a life aged x will die within t years from now. In other words, it is the probability that the future lifetime of this life aged x is less than a duration of t years, because a life would have died within the t years from now when they are aged x. It is also expressed as a TQX. Now, TQX is a death probability function. As performed earlier, we substitute. Where there's the t, we replace it with a number, say 10 years, a duration of 10 years, and x as 35 years. This is the probability that a life aged 35 will die within 10 years. Now, since the probability of survival and death are the opposite sides of the same coin, they are complementary probabilities. It means that the sum of their probabilities is equals to 1. Therefore, fxt and sxt is equals to 1 when we add their probabilities. Also, tqx plus tpx is equals to 1. For example, 10q35 plus 10p35 is equals to 1. We now look at the different links between the life table functions. We introduce two more life table functions known as Lx and dx. Lx is the expected number of lives that survive to age x out of a given reference group. Dx is the expected number of lives that die between the ages of x and x plus 1. For example, D20 is the expected number of lives that die between the ages of 20 and 20 plus 1. We can find dx through the Lx functions. Then dx is equals to Lx minus Lx plus 1. Now, tpx, tqx, Lx and dx are linked through the different expressions given. For example, tpx can be found by the L functions as Lx plus t over Lx. A tqx can be found by Lx minus Lx plus t over Lx. As you can see, this tqx is just a complement of the tpx, which was found by 1 minus the Lx function over the Lx. When we subtract this expression from 1, we will get the tqx function as given. Now take note, when t is equals to 1, we do not need to write 1 qx or 1 px. We would just need to write a qx or a px. So in this case, where we've been given that a qx is equals to Lx minus Lx plus t over Lx, then where there's a t, we replace it with a duration of 1. So Lx is given here, and the Lx plus t, where there's the t, we'll put a 1 over the Lx. Now we may recall that Lx minus Lx plus 1 is just the dx. So we substitute it with the dx, and the Lx comes here as it is. So Qx is also dx over the Lx. These are the different links between the different life table functions. After we know these links, we are now able to perform basic calculations involving these life table functions. To be able to do this, we need to be aware of the mortality assumptions that we would use. Now, mortality assumptions are just the projected expected death or survival rates for given populations. For this lecture, we will base our calculations on the English life tables for the males and female mortalities and survivals. These are also referred to as the ELT number 15 of the mortality tables. These tables give the mortalities for the population of England and Wales during the 90s. These life tables are also used worldwide for the actuarial professional examinations. We have an example where we've been asked to calculate the probability that a life aged 40 will survive at least 5 years from now. We've been asked to assume the English life table number 15 for the males' mortalities. Now, when we look at the question, we need to know what we are being asked to find. Here we've been asked to find the probability that this life will survive. So since we're talking about survival, we are being asked to calculate the survival probability function, TPX. Now, TPX, as we earlier mentioned, is linked with the life table function over this formula as Lx plus t over Lx. Now, since this life is aged 40, then where there's the x, we replace it with the 40. The t is the duration of survival, and we've been given in the question that it's a survival period of 5 years. So we are looking for a 5p40. 5p40, we express it in terms of the Lx function as Lx plus t, which means we should add the x and the t of 40 plus 5 would get L45, and Lx we would just get the L40 because this is the individual's age. So we will refer to the English life tables for the male's mortality. We will look up the L45. The English life tables give us the L functions for the different ages. So L45, referring to these life tables, gives us 95,521 lives that survive to age 45. When it comes to age 40, there are 96,500 lives that survive to age 40. As you will notice, L45 is less than L40. This is following the law of mortality, human mortality, that as we get older, the probability of survival reduces. That is why those surviving to a higher age are less. Then when we evaluate this fraction, we would get a 0.98985. We can express probabilities in terms of percentages also, and this can be written as 99%. This means that the probability that a life aged 40 will survive at least 5 years is about 99% according to these mortality tables. Example 2 is asking us to calculate the probability that a life aged 51 will die within 7 years from now. Now, we have been asked to assume the English life tables for the female's mortality. Because we are looking at a death probability, we are looking for a TQX. And the TQX is linked with the L function as given by this formula. It is Lx minus Lx plus T over Lx. So Lx, it means we are finding L51 because 51 is this individual's age. Lx plus T, we would need to add the 51 and the 7 and would have an L58. Lx, as we mentioned, is L51, and we evaluate these different L functions using the female's mortalities on the English life tables and would get these values. When we evaluate this, we're going to get a 0.031. This means that the probability that a life aged 51 would die within 7 years is equals to 3.1% according to the female's mortalities. We've come to the end of this short lecture on life table functions. If you have any questions on this lecture, please do send me an email at masakoshila.sm@gmail.com. Thank you very much for watching. Goodbye.